For centuries, humans have gazed at the stars, their eyes filled with wonder and curiosity. The night sky has always been a source of inspiration, a canvas of twinkling lights that has sparked countless myths, stories, and scientific inquiries. We have wondered about their nature, their origins, and their distance from us. What are these celestial bodies made of? How far away are they? These questions have driven humanity to explore the cosmos. Now, for the first time in history, we have captured a close-up image of a star outside our own galaxy. This breakthrough is not just a leap in technology but a giant step in our understanding of the universe. This is a monumental achievement, a testament to human ingenuity and perseverance. Scientists and astronomers around the world are celebrating this incredible milestone. It opens a new window into the universe, allowing us to peer deeper into the mysteries of the cosmos than ever before. This new perspective could lead to discoveries we can't even imagine yet. Imagine a fly on the moon. That's how small a star appears to us, even with our most powerful telescopes. The vast distances involved make it incredibly challenging to study these distant objects in detail. But now, using cutting-edge technology, we can see the surface details of WOH G64, a red supergiant star. This level of detail was previously unimaginable. Advanced telescopes and sophisticated instruments have made this possible. These tools are the result of decades of research and development, pushing the boundaries of what we can observe. This red supergiant star resides in the Large Magellanic Cloud, a neighboring galaxy. The image we have captured is not just a visual spectacle, but a scientific goldmine. This image is more than just a pretty picture. It provides us with invaluable data that can help answer some of the most fundamental questions about the universe. It is a treasure trove of information, offering insights into the composition, structure, and behavior of stars. This data will fuel research and discoveries for years to come. It allows us to study the life and death of stars in unprecedented detail. Understanding these processes helps us piece together the history of our own galaxy and the universe at large. This knowledge helps us to understand our own place in the cosmos. By studying the stars, we learn more about the origins of our own planet and the potential for life elsewhere in the universe. The stars are not just distant lights, they are keys to unlocking the secrets of existence itself. WOH G64 is a true giant of a star. Located in the Large Magellanic Cloud, a satellite galaxy of the Milky Way, this red supergiant is one of the largest stars known to humanity. Its sheer size and luminosity make it a fascinating subject for astronomers and astrophysicists alike. If it were placed in our solar system, it would engulf the orbits of Mercury, Venus, Earth, and even Mars. Imagine a star so vast that it stretches beyond the orbit of Mars, consuming everything in its path. The sheer scale is almost incomprehensible. This makes our sun look like a tiny speck of dust in comparison. The sun, which is already massive to us, pales in comparison to the colossal WOH G64. It's a humbling reminder of the vastness of the universe. Red supergiants are stars in their dying stages. They have lived for millions of years, burning through their nuclear fuel at a rapid pace. As they near the end of their life cycle, they undergo dramatic changes. They have exhausted the hydrogen fuel in their cores. This depletion of hydrogen leads to the fusion of heavier elements, causing the star to expand and cool, giving it a reddish hue. This causes them to expand outwards to enormous sizes. The outer layers swell up, making the star hundreds of times larger than its original size. This expansion is a prelude to the star's final dramatic end. WOH G64 is nearing the end of its life. As it approaches its final stages, it will undergo further changes, shedding its outer layers and losing mass. It will eventually explode as a spectacular supernova. This explosion will be one of the most energetic events in the universe, releasing an immense amount of energy and light. Studying stars like WOH G64 helps us understand the life cycle of stars. By observing these giants, scientists can gain insights into the processes that govern stellar evolution and death. This gives us clues about the history of our own sun. By comparing the life stages of different stars, we can predict the future of our solar system and the fate of our own star. It also sheds light on the formation of elements heavier than hydrogen and helium. These elements are forged in the intense heat and pressure of a star's core, and are scattered across the universe when the star explodes. These elements are the building blocks of planets and life itself. The carbon in our bodies, the oxygen we breathe, and the iron in our blood all originated in the heart of a star. The life and death of stars like WOH G64 are integral to the cosmic cycle of creation and destruction. Capturing an image of a star so distant is no easy feat. It requires incredible precision and advanced technology. This is where the Very Large Telescope Interferometer (VLTI) comes in. The VLTI is not just one telescope. It is a network of telescopes located in Chile. These telescopes work together to create a virtual telescope. This virtual telescope has the resolving power of a single telescope with a diameter of 200 meters. But the VLTI alone is not enough. It utilizes a powerful instrument called gravity. This instrument combines the light from the individual telescopes. This creates an image with incredible sharpness. It is this combination of amazing technologies that allowed us to see WOH G64 in such detail. When scientists first analyzed the image of WOH G64, they were met with a surprise. The star was surrounded by a massive egg-shaped structure. This structure, dubbed the cosmic cocoon, is made up of gas and dust. This cocoon is much larger than our solar system. It is thought to be formed by material ejected from the star itself. As WOH G64 ages, it sheds its outer layers into space. This material forms the cocoon we see in the image. The discovery of this cocoon was unexpected. It has sparked intense curiosity among astronomers. What caused this cocoon to form its unique shape? How does it interact with the aging star? These are just some of the questions scientists are eager to answer. The unusual shape of WOH G64's cocoon has led to several theories. Some scientists believe that the cocoon shape is due to the star's rotation. As the star spins, it could be flinging material outward in a spiral pattern. Another theory suggests that the cocoon's shape is influenced by the star's magnetic field. Just like our sun, WOH G64 has a magnetic field. This magnetic field could be shaping the outflow of material, creating the egg-like structure. Further observations and analysis are needed to confirm these theories. Understanding the dynamics of this cocoon will provide valuable insights. It will teach us about the processes that occur during the late stages of a star's life. Echoes of our past understanding: stellar evolution. This section delves into the intricate and fascinating processes that govern the life cycles of stars, from their birth in vast clouds of gas and dust to their eventual demise, which can be as spectacular as a supernova explosion. The study of WOH G64 and its cocoon is not just about a single star. It represents a window into the past, allowing us to glimpse the processes that have shaped our universe over billions of years. It's about understanding the grand cycle of stellar evolution. This cycle is a continuous process where stars are born, evolve, and eventually die, contributing to the cosmic ecosystem. Stars are born in nebulae, vast clouds of gas and dust. They live for millions to billions of years, depending on their mass, and then they die, often in dramatic explosions known as supernovae. This cycle is fundamental to the universe as we know it. When stars die, they release heavy elements into space, enriching the interstellar medium with the building blocks of new stars and planets. These heavy elements, such as carbon, oxygen, and iron, are essential for the formation of new stars, planets, and even life itself. Without this process, the universe would be a very different place. These elements become the building blocks for new stars, planets, and even life. The cycle of stellar birth and death is a cosmic recycling program that has been going on for billions of years. Planets, including our own Earth, are formed from the remnants of previous generations of stars. This means that the atoms in our bodies were once part of ancient stars that lived and died long before our solar system existed. Our own sun and solar system formed from the remnants of previous generations of stars. By studying these processes, we gain insight into the history of our own solar system and the origins of life on Earth. By studying stars like WOH G64, we are effectively looking back in time. These ancient stars hold the secrets of the early universe and the processes that led to the formation of galaxies, stars, and planets. We are witnessing the processes that led to our own existence. The light from these distant stars has traveled for millions of years to reach us, carrying with it the story of the universe's past. We are witnessing the processes that led to our own existence. This cosmic journey through time and space helps us understand the origins of the elements that make up our world and ourselves. This knowledge deepens our understanding of our place in the universe. It reminds us that we are part of a vast, interconnected cosmic web, where the life and death of stars play a crucial role in the ongoing story of the cosmos. It reminds us that we are all connected by the cosmic cycle of stellar life and death. This cycle is a testament to the beauty and complexity of the universe, and our place within it. A universe unveiled, the future of space exploration. The incredible image of WOH G64 is a testament to the power of human ingenuity. It showcases the advancements we have made in telescope technology. But this is just the beginning. New telescopes and instruments are being developed. These tools will be even more powerful than those used to observe WOH G64. They will allow us to see even further into space and unlock even more secrets of the universe. Imagine seeing the birth of stars in distant galaxies. Imagine witnessing the collision of black holes billions of years ago. These are just some of the possibilities that await us. As our technology continues to advance, so too will our understanding of the vast and mysterious universe we inhabit. Beyond WOH G64, what's next? The close-up image of WOH G64 has opened a new chapter in astronomy. It has ignited our curiosity and inspired us to push the boundaries of what's possible. This is just the beginning of our exploration of stars beyond our galaxy. Astronomers are already planning new observations of WOH G64. They want to learn more about its cocoon and its eventual fate. They are also searching for other distant stars to study. Each new observation brings us closer to unraveling the mysteries of the universe. The future of astronomy is bright. With each new discovery, we gain a deeper understanding of our place in the cosmos. So let us keep looking up at the stars and wonder, what other secrets are waiting to be revealed? Keep looking up! The universe is vast and full of wonder. It's easy to feel small and insignificant when we contemplate its scale. But remember, we are a part of this universe. We are made of the same stardust that forms those distant stars. So the next time you look up at the night sky, remember WOH G64. Remember the incredible journey that light from that distant star took to reach your eyes. Let it inspire you to learn more, to explore more, to never stop questioning and wondering about the universe and our place within it. Keep looking up, keep exploring, keep asking questions. You never know what incredible discoveries await you.